Welcome, my name is Mike Avgeros and I'm the Senior Sound Designer at Soho Sonic Studios. This is part 1 of hopefully a many-episode series on game audio using Unity. I'll be sharing with you some tools and techniques that I use to help you create better audio for your games. In this first episode, we will create a sound manager script which will help us add and manage our sounds in the game. You can download the game I'll be using for free on Unity's Asset Store and practice these techniques yourself. So let's get started. We'll create an empty script and call it Sound Manager. Let's open the script with your preferred editor. I'm using Visual Studio 2017. It needs to derive from mono behavior, but we can delete the rest. In the future, I'll also be showing you how to use scriptable objects. We need to write a few extra namespaces on top, one being unityengine.audio to allow us access to Unity's audio features, as well as unityengine.random to enable us to use the random range property. Before we start the Sound Manager script, I want to create another class and call it Sound Event. This class needs to be serializable, so we need to write system.serializable. Then, on the Sound Manager class, I want to create an array of this Sound Event class and call it Sound Events. We need to serialize it in the inspector, so we need to write serialize field. The reason I'm not writing public is because I don't need to access it from another script. Back in the Sound Event class, we need to create a few different properties that will help us manipulate the behavior of this class. One of them is a public string, which will store the name of our event and act as an ID for when we trigger it. We need a public reference to an audio source, which will help us play and position our sounds, and also an audio clip array where we will be able to import all our sounds that relate to this particular event. Next, we need to create an output for our sounds, which will be sent to the audio mixer. We can split the events into different groups when we start mixing. Now, to help us add a bit of randomness when playing back our sounds, let's create two public floats for minimum volume and maximum volume, which we can randomize between. We can restrict the values of those floats between 0 and 1. Let's add the same public floats for randomizing the pitch. These options will help us make our sounds a bit more interesting, as you won't hear the exact same sound twice. We also want to control our stereo positioning. This needs to go between a value of -1, which is left, and +1, which is right. For now, we'll leave it at 0, which is center. Let's make our class even more interesting. I want to allow us the option to trigger our sound after a specified time delay. You can add as many seconds as you want, but for now, I'll restrict it between 0 and 5. I also want to create another float whose value will be added and subtracted from the value that we set above for some extra randomization. You will see later how this will be used. Before we finish with this class, I want to create a few public booleans, which I will explain later how we use them. Some of them are quite common, for example, mute, loop, and play on awake. Now I want to create another public boolean, but I don't need to see it in the inspector, so we need to write hide in the inspector, and it needs to be false. The only reason I'm making it public is because I want to access it from another script. Now it's time to create our play function, which will trigger the clips from our audio clip array. First, every time this function is called, we need our play called boolean to become true. I want to declare our volume, so I'm creating a private float called random volume, which will generate a random value between the minimum volume and maximum volume that we have set in the inspector. Now I need to copy it and do the same for our pitch. So every time, we get a different value for volume and pitch, thus randomizing the sound. And of course, we need to declare that the volume of the audio source is the random volume float, and the pitch of the audio source is the random pitch float. Next, we want to declare all the other values of the audio source, such as the stereo position, whether it needs to be looped, if it needs to be muted, and also which group we need to send it in the audio mixer for mixing. Now it's where it gets interesting. We need to create an if statement and declare that if our delay boolean is false and also avoid repeat is false, we want to loop through the entire array of audio clips, so between clip 0 and the latest clip in the array. That is why we use the line audio clips.length, and then choose one of those audio clips, and below write audio source.play to play the chosen clip. By the way, the reason that we have declared our volume and pitch value inside the play function is because this way we can change it in real time when we play the game. Next, we want to create another if statement which says that if avoid repeat is true and delay is false, we want to create an integer, let's name it r, and instead of choosing a sound between clip 0 and the latest one in the array, we want it to start looking from clip 1. So basically it skips clip 0. Then it will play the chosen clip using audio source.play, and after it's played, we will move that clip to clip 0, so it will not be chosen again when it retriggers. This way, we avoid retriggering the same sound twice, thus adding some more randomization to our sounds. That's particularly useful in footsteps and any other Foley sounds. Now let's write that delay is true and also avoid repeat is true. We will create a private float called delay with a lowercase d, so it's different from our public delay float. This will generate a random value between our delay time minus random delay and the delay time plus random delay. Then we just need to copy the previous script when avoid repeat was true, but instead of writing audio source.play, we need to write audio source.playDelayed, and in the parentheses add the delay float we just created. Lastly, we want to write that delay is true and avoid repeat is false, which will trigger the sound after a delay, but choose a random clip from the array between 0 and the last clip in the array, so we just copy-paste what we've written above. We also need to create a stop function to help us stop our sound from playing, for example when it's looping. So we need to say that if audio source is playing, then stop that sound. Now back to our sound manager, we want to create a public static and call it sound manager, which will be the instance, and set it as null. Then, in the awake method, we want to make our sound manager instance into a singleton, so we write that if instance is not null, and if instance is not this, then we need to destroy this game object that contains this instance. Otherwise, instance equals this, and we need to write don't destroy this game object on load, so that it persists between scenes. After we have created our singleton pattern, we want our sound manager to loop through the entire array of sound events using a for statement and add or reference an audio source and store the values that we have set in the inspector. So firstly, we want to check if we have referenced an audio source outside of our sound manager game object. And if we haven't, we want the sound manager to create a new game object and add a suitable name to it. You can choose whatever you like. I'm going to name it like this. Then we want this game object to have the same vector3 position or coordinates as the parent game object, which is the game object that contains our sound manager. And finally, add a component of type audio source, so an audio source, to the game object that we just created so that it can play the clips of that sound event. Next, if we have enabled play on awake on a sound event, we want to call the play function here in the awake method so that this sound plays automatically when you play the game. We now want to create another function which will play our sound events. Let's call it play sound. It will need to take a string, which will be the name of the sound event. Again, we need the for statement to loop through all the names in the sound event array and play the first one it finds that has the given name. So we need to be careful how we name each event. We need to declare that if sound event's name equals _name, we call the play function we created in the above class. For safety, if it hasn't found that name, it needs to give us a warning in the console that it hasn't found the name in the sound events list. Similarly to the play sound function, we need to create a stop function to stop our sounds from playing. I'm just going to copy-paste the lines and rename where necessary. Finally, and possibly one of the coolest functions in our script, I need to create a coroutine. Similarly to what we did above, we need the for statement to loop through the entire array of our sounds and then write if the play function in the sound event class is being called, and this is why our play called boolean is useful in order to check that. And also, if randomize loop is true, which is the reason we created this boolean in the first place, and if avoid repeat is also true, it needs to check if delay is true or false, and if it's false, we want to wait until the audio clip is played once in its entirety, and that is why we write wait for seconds, and the seconds will be the sound events audio source.clip.length, so the length of the audio clip. If the delay is true, we will again create a private float and call it delay. It will be the same syntax as last time. It will generate a random value between the delay time minus random delay and the delay time plus random delay. Then we want to wait for seconds until the audio clip has finished playing like before, plus the amount of time generated by the delay float we created above. Basically, it won't play like a loop, but rather have gaps every time it retriggers. After all of this waiting, we want to safeguard the sound from playing on top of itself, so we need to write that if audio source is not playing, exclamation mark means not, then we call the play sound function we created above. Of course, it also needs to take a string, which will be the name of the event. Then we want to initialize our coroutine, so let's create a new function and write the line start coroutine. To conclude this technique, we want to now add this function, which we named initialize coroutine, in the update method, so that in every frame in the game, it checks these conditionals that we have set before, and if they are true, it plays the sound again and again. So basically, it will randomly choose audio clips from the array and play them one after the other without repeating the same one twice. This way, we can randomize a loop and make it sound more interesting. Let me give you an example. Let's assume that you have a 2-minute rain ambience loop. You can split it into 8 equal parts and add them to a sound event. If you're utilizing the coroutine, all of these 8 parts will play one after the other in a random order over and over again without repeating the same part twice. So you will generate an ambience that sounds like it was much more than a 2-minute loop. If you also utilize the delay and randomized delay, you can, for example, trigger thunders and gusts of wind after random time intervals so that it sounds like a long, natural, and realistic ambience. So this is the end of the first episode. Thanks for watching.